Welcome to Trimester 2, Day 12 of Calculus. Today we're going to talk about implicit differentiation. Up until this point, we have been working explicitly with explicit functions. These are functions that are written y in terms of x. So you'll notice here y is written just in terms of x and y is written just in terms of x. That's not always the case. So for example, you could have this relation, x squared plus y squared equals 4. So let's sketch a graph first. And a great way to do that is to plot points. So if y is 0, x is plus or minus 2. And if x is 0, y is plus or minus 2. So you might recognize or remember that this is a circle centered at the origin with radius 2. So those are the intercepts. And now you can draw in a circle. Or draw it in a little better than me right there, but it is a circle with radius 2. So now we're going to find the slope at x equals 1, which is right here. X is equal to 1 right there. So we're looking for the slope of this tangent line. It's going to be negative, but exactly how negative we have to figure out. We're going to do it in two ways. First, we're going to solve for y. So we're starting with x squared plus y squared is equal to 4. So that is not written explicitly, so let's write it in terms of x. So y is going to be plus or minus the square root of 4 minus x squared. Now the positive one here is going to be the upper part of the arc, and the negative one will be the bottom part of the arc. Now we're looking where x equals 1 at this point. We've chosen this one right there. So let's just take the upper one. Let's just take the upper one. So we're just going to take the positive one in this case. So y is equal to the square root of 4 minus x squared, because that's where we've chosen to look at that point right there. And now let's find the slope, so we need to find the derivative. And another way to write that is 4 minus x squared to the 1/2 power. So if we're going to take the derivative of this, y prime is going to be, you drop the 1/2 to the front, and you get 4 minus x squared to the, subtract 1 from that, you get negative 1/2. And now you have to use the chain rule. The derivative of the inside is negative 2x. So let's simplify a little bit. The negative 2, that 2 cancels there. So you end up with y prime is equal to negative x times 4 minus x squared to the negative 1/2. So let's figure out what the slope at x equals 1 is. We need to plug in 1 right there. So y prime evaluated when x equals 1 is going to be negative 1 times 4 minus 1 squared to the negative 1/2. So we end up with negative 1 times 3 to the negative 1/2. And you might, now you need to remember that when you raise something to the negative power, it's 1 over that thing to the power. So that's going to be negative 1 over 3 to the 1/2, which is negative 1 over the square root of 3. And that matches the slope. We assumed that the slope of this line was going to be negative, and we didn't know exactly how negative it was going to be, but it is negative. Okay, so you might also remember that there's a negative part here. So if we'd done this whole thing with a negative in front, we would have done the slope right here. And the slope of that one right there is going to be the exact same as the one above, but it's going to be positive. All the math would be the same, but that negative would be different. So let's do it implicitly. So what does that mean? Well, we have this x squared plus y squared equals 4, and we were able in this case to write it explicitly, meaning isolate y, but sometimes we're not able to do that, or not able to do that very easily at all. So instead what you're going to do, and there's different notations, and you're going to see different notations, and I'll explain them when they come up, but we're going to say y is equal to some function of x. I like writing it that way. So x squared plus f of x, this is just for keeping things straight, is equal to 4. And now we're going to differentiate with respect to x. We're going to differentiate with respect to x. So if we differentiate this with respect to x, the derivative of x squared is 2x. The derivative of the next term is going to be 2 times f of x, but because of the chain rule, we need to multiply by the derivative of f. And remember, the derivative of a constant is 0. The derivative of a constant is 0. Now we can substitute back in f of x is y, and f prime is y prime. So we have 2x plus 2y, y prime is equal to 0. And we like writing our derivatives in terms of y prime. So let's isolate y prime. So let's divide by 2 first, and you get x plus y, y prime is equal to 0. So y prime equals negative x. So y prime is equal to negative x over y. So this is our derivative, but in terms of x and y. So how is this helpful? Well, if you want to find the derivative at a certain place, you need both x and y now. You need both x and y. So for example, this point right there, we knew it was 1. But what is the y value when you plug in 1 there? So it's 1 squared plus y squared is equal to 4. So y squared is equal to 3. So y is equal to the square root of 3. So the point right there is 1 comma root 3. So if we wanted the slope right there, we'd plug in the point 1 comma root 3. If we plug that point in, what do we get? Y prime at the point 1 root 3. Y prime at that point is going to be negative x, so negative 1 over the square root of 3. Hey, is that the same thing as we got right there? It is. This right here is generally going to be a lot less work. It's also going to be preferable because sometimes you can't solve for x. Sometimes it's super, super, super hard to solve for x or just impossible, so you do it implicitly. Again, there's going to be different notation. I like doing this to remember that you have to come out with this f prime right there. You'll see other notation and I'll explain it to you as I come up, but that's how I like to write it. So for example, we have this one where you really can't solve for y. It's really hard. It's really hard to solve for y. So instead we're going to do it implicitly. So remember I like substituting f of x for y. So we say y is equal to f of x. Just to remember that we're going to have to do f prime every time we take the derivative. So I'm just rewriting it now. F of x equals negative 6. All I've done is rewrite. That's it. So now we take the derivative. We drop the 3 to the front. We have 3 f of x squared, but because of the chain rule, we have to have f prime of x. And now this is important. For this one, we have to use the product rule. So it's the derivative of the first times the second plus the first. Remember, I'm doing just this, so that negative is going right there. So the derivative of the first times the second plus the first times the derivative of the second, f prime of x, like this. And remember, the derivative of a constant is 0. So now let's substitute back in y equals f of x. So we have 3y squared y prime minus, in parentheses, y, that's that one right there, plus x y prime equals 0. So let's distribute that negative. You get 3y squared y prime minus y minus x y prime equals 0. We want to now isolate y prime. So let's put this other y on the other side. So you end up with 3y squared minus xy prime, and I'm taking this one and putting it over there, equals y. Now let's, oh, there's a y prime right there. Let's factor out, because we have these y primes, both of those, factor them out. So you have y prime times 3y squared minus x is equal to y. Now we can divide both sides by 3y squared minus x. So we have y prime is equal to y over 3y squared minus x. So in this case, it's okay that y is on the other side because we're differentiating implicitly. So if we want the derivative, if we want the rate of change at a specific point, we need the whole point, the x and the y value. Up until this point, we've just needed the x value. Keep in mind, too, that another way to write this is dy dx. It's the same thing as f prime of x. In this case, it's f prime of x and y, but f prime of x is fine. So lastly, you could have both x and y being in terms of some other variable. So what that means is x is some function of t and y is some function of t. So what I like to do is rewrite it, but in this case both of them, x of t minus 2 times y of t, like this, equals 5. So now when we take the derivative, we have to be careful and treat both of them the same way like we did the f of x before. Oh, this is cubed and this is squared, sorry. So let's take the derivative. You drop the 3 to the front, you get negative 9 x of t, like this, squared, but then we have to multiply by x prime of t, because it's the derivative with respect to t, minus 2, and not in this case, sorry, 4, because it's 2 times 2, 4 times y of t, but because of the chain rule, we now have to multiply by y prime of t equals 0. So what you can do is you can substitute back in here, so it's going to be negative 9x, and you can say it as dx dt, or you can keep it as x prime, which is fine, so x prime of t minus 4y y prime of t equals 0. Another way to write it, and these are going to be the same, negative 9x dx dt. This is the same way, just different notation. Dy dt. Dy dt. Because we're differentiating with respect to a third variable. This is where you would actually stop, because it doesn't say what to isolate. It doesn't say what to isolate. So the big thing to remember is we've been dealing with explicit functions up until this point, where y equals f of x. Now we have a method where we can, instead of solving for x, because sometimes this is not possible, we substitute y equals f of x in for y. We take the derivative. And remember, we're taking the derivative with respect to x, so it's 2x there, but over here, it pops out the y prime. It's really important. We'll practice.